Hello again, my name is Héctor and I'm going to expose you a new experiment which is called instant ice. Okay, for this experiment we'll only need the following: about 200 milliliters of water, sodium acetate around 400 grams, a recipient which will be able to heat it, something to stir a solution, and something to wait. Okay, so let's begin. First, we'll pour this water, this 225 milliliters. This was my choice, but the point is to oversaturate this water with sodium acetate. So we have to pour it right here, and we'll heat it until its boiling point. When the experiment is finished, I'll explain all of the scientific basis and all of the scientific points of this experiment. But first, we'll focus only on the process of the experiment. So the water is boiling right now. So we have to pour right now the sodium acetate on it. We'll need around 400 grams for oversaturating the solution. So right here, we'll pour some of it. So now we're gonna pour it. The measure is only its only purpose is to oversaturate the solution. So when we observe that the solution is already oversaturated, it's a good point for stop adding sodium acetate. So while it's heated, we shall continue pouring it. It seems to me like it's enough right now. So now we have to stir it constantly. So as we continue stirring the solution, it will be normal. It is normal that there are some residuals on the bottom of the pan in this case, which we will not use. As we can see right here, there are residuals. These are not so important, but it means that solution is already oversaturated. So in a few moments we will pass the solution to a glass container for it to
put it on the fridge.
Cool on the fridge. Thank you. About 30 to 60 minutes. So right now I'm going to cool it. So we have poured the solution into 2 glass containers, in this case well, water, used for water at dinner. And with this solution we will let it cool. It should be a little dense, so now we're gonna cool it. Yet as we can see on this one already, because of the change on the temperature, it has become a little bit more solid. Yet it's normal. So we'll pass it to the fridge and let it cool for about an hour. That water is boiling. We're gonna add the sodium acetate, trying to oversaturate it for obtaining the wished reaction. So we add, react more, seems like enough. We're gonna stir. Seems to me like we need more, so we'll add a little bit more.
I think that's fair enough. But what are you going to do with that thing that fell down?
We add a little more. Now that the solution is mixed completely, we're gonna pass the solution to some glasses in order to later heat them. we will save this on the fridge. Would you handle that, me?
It's hot.
Thank you very much. So after leaving the solution 1 hour to cool at the fridge, now let's see if our experiment was successful. What's proceeding now is to transfer the solution towards this container and within a few moments we'll hit it and let's see if it works. So let's see. So we have left these two solutions in rest like by 10 minutes. So what we are about to do is to finish the experiment. We will pour the water into some plastic cans, which you can see have nothing inside, and we're hoping to find the crystallization of the sodium acetate transferred and seen as ice. Okay, so let's see. Here at the glass we can actually see our expected ice. Let's see if by making contact to the solution poured into the container, we can create crystallization. Yet we have already obtained ice in here. So yeah, indeed, we can see crystallization. We'll just pour the liquid into another container for you to observe the crystals right here. At the first container. Here at the bottom we can see this one and these ones. As you can see right here, it's solid and it has been cured because of temperature. Here we have it. Instant ice. And without making the solution to be on the freezer and only on the fridge. So, experiment has been successful. And now I'll explain the reason of the ice by the use of sodium acetate. Okay. For concluding this experiment, I'll explain test A and test B. Okay. On test A, which is the first we showed to you, we really oversaturated the solution, creating this. At the moment that the solution came out of the of the pan, which was boiling, temperature changed. It stopped receiving heat to a very high level, which it was created by fire. So when the temperature changed and it stopped receiving too much heat, we could observe first an isothermic reaction on test A. Why? Because temperature inside the solution was the same, yet the heat, the energy received by the fire stopped. So it's an isothermic reaction because it maintained its temperature at the same level, could be said, through the whole experiment, even when we took it inside the fridge. Actually, we felt it like 2 or 3 times inside the fridge, and it still was hot. So I'll ask my camerographer to prove my theory. So, what's the sensation you feel by grabbing test A?
Well, I feel that the glass is too hot by the outside, and the inside of the substance it's also hot, but not as burning my hand, but it's so hot.
Where would you describe it, which is hotter, on the glass or the crystal itself?
Well, I could say that it's the crystal.
The crystal.
Test A, I feel that the glass is hotter than the crystal.
Okay, thank you very much. So, switch. And now, after hearing the witness, we can say that this is also an external reaction because it creates heat to its outside. In this case, the crystal inside the glass, as you can see right here, creates enough heat waves for the glass to be felt hot and warm, which proves the difference between temperature and heat. Temperature is the state of kinetic energy which is created between molecules of a substance or any thing, while heat is the energy, the transfer of these molecules, the increase on their vibration for the increase of temperature. Here we can really see the difference between heat and temperature. Its temperature, for example, on this part of the glass, if another witness will allow me to tell, is it or not the glass temperature colder right here at this spot where it's not making any contact with the solution than right here when it's really concentrated the solution?
Okay, here is cold, but on this side is hot, sorry.
So here we can, thank you very much. So, as I said earlier before, here we can test and prove the difference between heat and temperature. On test B, we could observe the crystallization of sodium acetate because of the changes in temperature. First, when it was on a boiling state, the water and the solution, it was just a liquid solution. Actually, it was homogeneous solution because we could not appreciate what was appreciated on solution A. On solution A, we could observe that it was more dense and it had a lot more residuals than here. It was almost in test B, it was almost. We could observe that by the changes of temperature of the environmental temperature on the solution, first we had that it was receiving a lot of heat by being in contact with fire at the pan. Then temperature changed a lot. It was transported to the fridge, where temperature at the fridge is to 3 Celsius degree. Yeah. And then it was taken outside of the fridge to the table, where it was left 10 minutes for temperature again to be on environmental temperature could be set. We obtained these crystals, which allows us again to prove the difference between heat and temperature, as I've explained on test A, which is the clearest case in proof. So that's it. Crystallization of sodium acetate is owed to the change in temperature from one point to another spot to environmental temperature. Thank you very much, and see you.